Okay, so we actually are going to have different titles for each of the 3 pages. They're all going to be related to the same topic of slope, but each one we're going to talk about how do we find slope different ways. So the first page is going to be lesson 3-3, slope, and we're going to be talking about finding slope using a table. And then today's date's 11/19/19. And we're going to start with a Frere model. And so a Frere model, I think we've done one before, where there's kind of a circle in the middle, and then we create branches coming out of it, surround it all up, and we end up having 4 boxes around our shape. Actually, I think I'm going to make this one go a little lower. Okay, and our word of the day is slope. And in the Frere model, we're going to be adding, in the upper right is talking about the definition. If I could spell definition. I couldn't spell characteristics earlier today. The definition of what is slope, and then we are going to have facts and characteristics. That's a lot of letters. Oh, my. The bottom left is examples. So what is slope look like? Things that have to do with slope. And then the bottom right is going to be non-examples. Okay. So Frere model's job is just to look at an idea, concept, just a vocab word from 4 perspectives. So let's start with the definition. So slope is the ratio. So remember, a ratio is a comparison of 2 numbers, so I never want to see a mixed number ratio. I don't want to see decimals, though I have occasionally seen that sometimes. It should just be a fraction, improper, or proper. The ratio of the change in y, which is going to be a vertical change, to the change in x, which is going to be a horizontal change. That'll be fun listening to this video and hearing people shouting on the outside the door. Some facts and characteristics. Well, you guys probably studied in last year other words for slope. Instead of the change in y over the change in x, it would be rise over run. For the vertical change is the rise, for the horizontal change is the run. Now, we have different values for rise and run. So rise, if you rise up from one point to another, that's positive. If you rise down from one point to the other, that's negative. So you get signs on the direction that you're rising or running. On run, same idea. If you go to the right, that's positive. Oh. So run, if we go to the right, it's positive. And if we go to the left, that's negative. So that's from one point to another. The other thing that's kind of interesting that nobody really knows why is that they use the variable m to represent slope. So that's the variable for slope. Some people thought maybe it was French for mountain, but no. They thought maybe it was something that had to do with Greek or Latin, but they haven't come up with anything yet. So I honestly don't know. I know S means seconds, so they needed to find something else. So I don't know where M came from, to be honest with you, but that is our slope. So a lot of people stick with the mountain thought, perhaps. So we're going to go ahead and create a little graph over on this one, and we're actually going to put numbers and everything on it. We're going to graph 2 points and then show you the how to rise and run. So, because that's pretty much what you guys, I think, were doing. I don't know if you guys did a formula last year. Did you guys learn how to calculate slope just knowing the coordinates? Yes, no? Okay. Okay, so we're going to graph 2 points. I'm going to put them in red so they'll stand out. So we're going to put one at -2, 0. And then we're going to put another one at 2, 2. And then we'll draw our line through that. And then when we do rise, you can go, and it doesn't matter if you start at the low point and go up or the high point and go down, you're going to get the same answer. So it's whatever you decide, but the direction you move is going to be related to a sign, okay? So here's my rise, and I rose up, and it looks like 2 places. So that's going to be a +2. And then from there, I'm going to run over here, so that's my run. And it looks like I moved 1, 2, 3, 4 places to the right. So that would be considered a +4. So when I do slope, and it's rise over run, I'm just going to substitute the numbers in that I got. So my rise number was 2, and my run number was 4. And then the only thing I need to do is to simplify that down to lowest terms. So the slope is 1/2, 1 to 2. Okay. So examples where we do not have a slope. So I'm going to draw 3 just basic coordinate systems. So first thing that is not going to be having slope would be a circle, because it has to be something that is a constant rate of change, which would give us a line. So we can only talk about slope technically when we're talking about linear functions. Another one would be parabolas. Okay, we don't have a constant rate of change. Okay, and then a third one would go with I think this is a sine function. It's been so long since I've had to deal with it, but I think it's fun to draw. That also doesn't have a constant rate of change. So those are non-examples of our having a slope. Okay, so let's talk about how do I find a slope from a table. And I can't remember which question was, but somebody asked me a question, and basically that's how I found it. That one, the slope I think was 1/5. So we have a little table. We have x's and y's, so 2, 4, 3, 9, 4, 14, and 5, 19. And I start doing what we were doing yesterday, is I'm looking what happens to get from 1x to the next. I added 1 to 2 to get to 3. I added 1 to 3 to get to 4. I added 1 to 4 to get to 5. For my y's, I added 5 to 4 to get to 9. I added 5 to 9 to get to 14. I added 5 to 14 to get to 19. So then I take those, and I'm going to follow this process. First, I'm going to look at the change in y. So every time it increased by a 5, so that's a positive 5. Next, I'm going to look at the change in my x. And that was a positive 1. And then third, I'm going to remember that slope is equal to the change in y over the change in x, which is going to equal my positive 5 over my positive 1, which equals good old 5. So then we would say the slope is equal to 5. Okay. So if you haven't figured it out, you have a constant rate of change. Which really is known as slope. When you see these two things happen. Oh no, I keep picking green. You have all x's increase by the same value. And all y's increase by the same value. Now, I am going to kind of say that there's an opportunity that, let's say it went from 2 to 4 and 4 to 14. Well, 2 to 4 increases by 2, and 4 to 14 increases by 10. However, if I wrote 10 over 2, it would simplify down to 5 over 1. So it is possible to have a different numbers, but the ratio would still have the same value, okay? Denny.
Wait, so what's the triangle doing there?
Oh, that means change. That's a Greek letter. Delta means change. So let me put that over. I'll put it over here. So delta, and we take it in math and science to mean change. I had seen it so much throughout all the science classes and all the math classes I took in high school and college that that's what I automatically go to. Like for me to write the word water is super hard because I'm used to just writing H2O, okay? Because it was so ingrained in me over and over and over again with all the classes I took. So it just means the difference, okay? So change for us in math means difference. So it's just a shortcut way of writing that. I think we put that in the notes yesterday, but I said I'd talk about it a little bit more. Wasn't sure. All right, so that does it. Finding slope from a table. We're going to go to the next page. And I'm going to see, I think I'm going to do a little bit of graph paper. Let's see what medium looks like. No, let's go small. So I'm going to use graph paper on the back of this one. So we still are on lesson 3-3. But this time we're going to find slope from a graph. And we're at 11:19 still. And so what I'm going to do is give you a couple graphs. We're going to figure out the slopes, and then we're going to write down the steps that we took. So this graph is going to go basically 5 to 5. So let's see. 5, 4, 3, 2, 1, 0. 1, 2, 3, 4. Here's my X, here's my Y. I'm going to mark in my tick marks. Even though I have graph paper, I'm still marking in those tick marks. 2, 4, 6. We got 2, 4. -2, -4, -6. -2, -4. We're going to graph 2 points again. I'm going to do them in red so they're easy to see. We're going to go -2, -2. I'm just going to write out the ordered pair so you can see that. And then 4, 6. Oops, I didn't go up high enough. Let me make him go up a little higher. And so we've got 4, 6. And then we'll draw our line through that. It's 2 points. Okay. And then let's do the next one over on the right side. This guy's going to go up higher and wider. Let's see, let's do 1, 2, 3, 4, 6, 7, 8. We'll go about 8 for each of them. I'm going to do a little shortening. This is your x-axis, your y. Put in some numbers. 2, 4, 6, 8. 2, 4, 6, 8. -2, -4, -6, -8. -2, -4. -6, -8. So the 2 ordered pairs I want to graph on this one are going to be -1, 2. And then 8, -6. And then we're going to connect them. All right, so let's go back to the first one. And what we are familiar with from last year would be rise over run. So I'm going to go from the bottom point, and I'm going to just rise till I'm on the same level as my other point. So this is my rise. And then I'm going to count what my rise is. So I went up 1, 2, 3, 4, 5, 6, 7, 8. So +8. Now from there, I'm going to run to the right till I run into the point. So this is my run, and I have 1, 2, 3, 4, 5, 6. It's also a positive. So if I want to figure out my slope, we're going to have rise over run. And we're just going to substitute those numbers in. So our rise was 8, and our run was 6. And the only thing we need to do is to simplify if possible. So these two have a 2 in common. So we always simplify. And that gives us our final answer, that our slope is 4 to 3, or 4/3. Okay? So we rise from one point to the next, a rise of 4, run of 3. Rise of 4, run of 3. Hudson.
Is it possible to write that as a mixed number and not as what's that?
Never. Because it's a ratio, and a ratio involves 2 numbers only. Okay? All right, so on this next guy, let's do him. So we're going to figure out rise and run. So let's start with the rise. And if I started on the left, I would actually end up rising down. So my rise is down, which makes it a negative number. And I have 2, 3, 4, 5, 6, 7, 8. So it's a -8. And then my run is going to go over till I bump into that second point. So my run is going to be a positive, because I went to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now I'm going to figure out slope. And it's going to be rise over run. And we're just going to pop the numbers in there. So the rise was a -8, and the run was a +9. And that would be my slope. Would be, I didn't write it over here. Just -8/9. Okay? So, first off, this is what the steps were, is we found 2 points. But here's the deal. These 2 points need to have integers only. So, integer values. So, find 2 points, integer values on the line. So, you don't want to be dealing with fractions and decimals because, again, that's kind of a guess game for us. Second thing we're going to do is we're going to use rise over run to figure out slope. Sorry. Then we're going to count the rise. Rise. Count the rise. And it can either be counting up, which is positive, or counting down, which is negative. And we're going to count the run as well. If we go to the left, it's positive. I mean, to the right is positive. If we go to the left, that's negative. And then we just substitute the values into our formula. And the key, simplify. All right, so page 3, now we're going to talk about the slope formula, which is basically how I do it. Every once in a while I'll do rise over run because I want to change the pace. Slope from the slope formula. And there's no reason why you can't memorize this. This is not the hardest formula in the universe. Where are we at? 1919. And actually, I'm going to take off the chalkboard on this one. We don't need it. So, I'm going to talk to you about how we write these ordered pairs. So, I'm going to color code them different ways. We're going to do the x value is pink. And then we're going to have the y value is going to be blue. So I use that little 1 to signify this is my first ordered pair, x sub 1, y sub 1. Okay. Then we've got our second ordered pair, because remember we said we needed 2 with integer values. So now distinguish these x's, I'm going to call him x sub 2, and to distinguish the y's, I'm going to call him y sub 2. So these are basically the coordinates of 2 points on the same line. Okay, so that's where we're going to start with that one. So we're going to take this idea that I mentioned yesterday, mentioned again today, where slope is the change in y over the change in x. So change, remember, is a subtraction process. So we're going to take our y values and we're going to subtract them. Now, it doesn't matter if you do y sub 2 minus y sub 1 or y sub 1 minus y sub 2. That order doesn't matter, but once you make a commitment, the guy underneath has to be from the same ordered pair. So because I put the y sub 2 in front, that means under the y sub 2 goes its partner, x sub 2. Okay? So, again, on top we've got rise, and on the bottom we've got run. So that's how we're transitioning away from that to this guy. All right, so we're going to do 2 examples, one just a basic one, and then one is a tricky one that a lot of people struggle with. So this one just says find slope. and we've got 2 ordered pairs, 3, -2, 5, 7. Okay, so what I'm going to do is explain to you how I rarely make a mistake when I do my slope putting my numbers in, because I follow the same idea every single time. So I look at my first ordered pair, and I notice I've got 3, -2. So I'm going to take that ordered pair, and I'm going to rotate it left 90 degrees. So that's going to put -2 on top and the 3 underneath. And I'm going to write it like a ratio, okay? Now I want you to look at 5, 7. I'm going to do the same thing. I'm going to take that 5, 7. I'm going to rotate it 90 degrees left. That's going to plop the 7 on the top and the 5 on the bottom. And then all I do is connect up between them and put minuses. And I never get things wrong if I constantly, even though, I've been doing math for a lot of years, whoop, whoop, and then I'm good. And my whooping is just me moving that y value up to the top of a fraction and the x value underneath, okay? And then I just start doing math, okay? So I see this is going to be -2, take away 7, signs are the same, so I add and I get -9. 3, take away 5, signs are different, bigger number is negative, and 5 take away 3 is 2. And then I can't have a double sign, so I eliminate the 2 negatives, make a positive, and that's my slope, is 9/2. That's it, okay? The one that gets tricky is this one. Find the missing coordinate. So this one, I'm going to give you a coordinate, and I'm going to give you a partial coordinate, and strangely enough, I'm going to give you slope. Oops, sorry, not negative. Okay, so those are the 3 components you're going to get. I'm going to do the same exact thing I just did before. I'm going to use that slope formula, remind myself what it is. M is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I was kind of taught it this direction, so my brain always goes with the 2's in front and the 1's in the back. But again, you'll get the same answer the other way. So then I start plugging numbers in. The strange thing is I know slope. So I get 1/3. And then I'm going to do the same thing that I just talked about with my 2 ordered pairs. Take that 1, 4, 90 degrees rotation to the left. That puts the 4 on top, the 1 on the bottom. I'm going to take that -5r. I'm going to do rotation 90 degrees to the left. That puts the r on top and a -5 on the bottom. Then I'm going to connect them and separate them with minus signs. Okay? So you should be able to see that there is some simplifying we need to do in the denominator of the second one. So I'm going to go ahead and do that. So I get 1/3 equals 4 minus r over 1 take away -5 is the same as 1 plus +5. So that would give me a 6. Now my job is to get r alone. So what am I going to do first? And there's a lot of different ways to do this. Samson, what do you want to do?
Multiply both sides by 6.
Okay, you know what? That's funny because that's the same exact thing they said in period 1. So this is going back to chapter 2 when we talked about eliminating fractions out of fractions out of equations. So this is going to become a 2, and the 6's eliminate. So this gives me 2 equals 4 minus r. And then I just continue and I solve. So I subtract 4 from both sides. That gives me -2 equals -r. Divide both sides by -1 for whatever reason. You guys like to not show me that step. And you get 2 equals r, which we're not going to keep because we were solving for r. So we're going to turn it around using symmetric property, and we get r equals 2. But let me show you a different way to solve it. What is that called? Fraction equal to a fraction. It's called a proportion, right? So I can do cross products. So I'm going to multiply this direction and this direction. So that's going to give me 3 times the quantity. 4 minus r equals 6. Now I could divide both sides by 3. That's one way. I could distribute the 3. Doesn't matter. This gives me 4 minus r equals 2. Subtract 4. Negative r equals negative 2. Divide by negative 1. And we get r equals 2. So there's multiple ways to get the correct answer. Docere is pointing at that direction because he's right at the answer saying, I like this one. But no, it's up to you guys to decide how to actually solve that. So that's it for today. Woo, that was a lot.